All right, so today we're going to talk about area. We're going to focus really on three shapes: a parallelogram, a triangle, and a circle. We can break everything down into those shapes. Typically, I would also go through like rhombus, kite, and trapezoid, but I'm going to show you how we can break those down, and we really only have to know three formulas. I did give you the three formulas, and I'm guessing you're not surprised by any of them, right? You've found the areas of parallelograms and triangles before, and probably circles as well. Okay, but I did put a reminder there in terms of parallelograms is base times height. Remember that base and height have to be perpendicular to each other, right? Same thing is true with the triangle. Remember, we talked about heights a while ago in when we were doing constructions. We call them altitudes. We were constructing altitudes, and we said sometimes the altitude is inside the triangle, sometimes it's a part of the triangle, sometimes it's outside of the triangle. Okay, so I gave you like three different scenarios there. That's again 1/2 base times height. And then the area of a circle is pi r squared. Normally we discover all these, and I want to kind of talk to you about where they all come from. Okay, and you've probably talked about it in terms of a parallelogram and a triangle, but I also want to put it together with the circle. So I'm going to take a little trip down memory lane here. Back in probably about first grade, your teacher gave you something like this and asked you to count the number of squares. So you went through and you counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And they said, okay, the area of this rectangle is 12 square inches or 12 square blocks, whatever they want to call it at that point, right? Okay, as you got a little bit older, they started talking to you about these things called arrays and grouping them, right? And they said, okay, well, this is 4 wide and this is 3 tall, and I can actually just multiply those together instead of having to count out 1, 2, 3, and so on, right? So you said, hey, I can just take 4 times 3, and I can still get my 12 square inches. So that's where the area of a rectangle comes from. In fact, you're just counting the blocks and you found a shortcut, right? Base times height will give you the area of this rectangle. It also just gives you a chance to count those much quicker. All right, so every shape that we find the area of is really based on a rectangle. All right, so let's start with the parallelogram. So a parallelogram, keep in mind, we know it's base times height, right? But we're trying to figure out why. So keep in mind, if this is my height is perpendicular to my base, I can take this piece, cut it off, and move it down here. I've still used up that entire blue base. I still have the exact same height, but what shape have I made? I've now made a rectangle, and the rectangle, the area is base times height. Okay? Again, I'm sure you've seen that part before. I can think about a triangle in somewhat the same way. I want to take this triangle or multiple triangles and turn it into a shape I already know. So what if I duplicate this triangle and I turn it around and I put it together with this other triangle? What overall shape here did I make? A parallelogram. How do we find the area of a parallelogram? Base times height. But I don't want 2 of them, right? I only want 1 of them. So I got to cut that area of the parallelogram in half. So either divide by 2 or multiply by a half, either way. Is that okay? All right, again, you've probably seen that before. All right, but what we're building up to now is finding the area of a circle. All right, so to find the area of a circle, typically I have you cut out a circle, fold it in half, cut it in half. Take each of those halves, fold it, cut it, take all those little parts, fold it, cut it, and so on. Until we have 16 congruent sectors. A sector is like a piece of a pie. It's a pie wedge. Okay? Excuse me. So I cut it into 16 congruent sectors. Then I take each of those wedges and I'm going to alternate their directions. So one up, one down, one up, one down, one up, one down, and so on. All right, so what general shape does this arrangement make? About a parallelogram, right? Not perfect, but about a parallelogram. How do I find the area of a parallelogram? Base times height. All right, so let's think about the base and the height of this funky looking parallelogram. So my base is really like this curved, these curved pieces here, right? Where do those curved pieces come from? The curved part of the circle, right? They're all a bunch of little arcs put together. Okay, so if I were to take all of these arcs and put them all back together, it's really all of these red arcs, right? What is that? That red line, what's that really called? Circumference, right? So that red line is circumference, but in this arrangement, I have half of my circumference up top, half of my circumference on the bottom, right? Half the curved parts up top, half on the bottom. So this base is 1/2 of my circumference. So 1/2 of 2 pi r. Okay, now let's think about the height. Let's think about the height of my parallelogram. What is that blue line in terms of the circle? It's a radius. Okay, so if I'm thinking about area of a parallelogram, my base we said was 1/2 times 2 pi r. My height we said is a radius. Well, half of 2 is just 1. Pi times r gives me pi r squared. So really, the area of the circle really just built from the area of a rectangle. Now, I only cut this circle into 16 pieces. I could have gone 32, then 64, 128, and so on. Right? I can keep going, keep going, keep going. So the more slices I cut it into, the less pronounced that curved arc is. Right? If I keep cutting it, cutting it, cutting it, cutting it, it really becomes so minuscule that it really then does end up forming your parallelogram. Does that make sense? All right. So I want to spend some time talking about where those formulas come from, because I think it's kind of cool how it starts to tie together. And even if you don't, this is where you should lie to me about how amazing that was, and probably the best part of your day right there, right? That's what I thought. Okay. So we're going to practice a couple of things. I'm going to throw in some Pythagorean theorems, some special right triangles in here, just to show you how it can all come together. One thing, I brought in this first problem, I know it's super simplified, but what I want you to get used to doing is writing out your formula that you're using. Okay, it's good practice for us, but also when you move on, like in physics. Physics, you use a lot of formulas, and people are not very good about writing out the formula and substituting into their formula. So the science teachers have asked us to kind of work on that. So we're going to do that as well. So because it's a parallelogram, I know area equals base times height. Okay, so I'm just writing the formula that I'm going to use. So the base in this case is going to be what? 4. My height is 5. Good. So I can multiply together and I get 20 square yards. Is that okay? Again, not meant to be really complicated here. All right, let's look at the next one. We have a parallelogram again. So I know it's going to be area equals base times height. So my base really goes from here to here, but I don't have that entire length. So how can I find this little section? Right, I can use my Pythagorean theorem because I know the height here, which actually ends up being a leg, and I know the hypotenuse, right? So I can do 14 squared plus x squared equals 15 squared. So go ahead and figure that out and go ahead and round to the nearest tenth, 1 decimal place. What do we get? 5.4. Is that okay? All right, so now my base is that entire piece, so it's going to be 21.4. My height then is what? 14. So I can multiply it together. I get 299.6, I believe, square units. Good. All right, next one. Again, we have a parallelogram. I'm going to start with area equals base times height. All right, so my base and my height have to form a right angle. So I'm really looking at these two pieces, right? Kind of wonky if you want to turn your head sideways, maybe it's a little easier to see it. So I have my base. My base is 13, but I need to find that height. So here's our special right triangle. We have a 30, 60, 90 triangle here. The 10 is what part? The short leg, long leg, or hypotenuse? Short leg. I need to find the long leg. So what's that height going to be? 10 radical 3. Good. So the height here is going to be 10 radical 3. And you can leave it like that. You could multiply it out in your calculator. I don't care. You would get 130 radical 3 square units. Is that okay? All right. Next one, we have a triangle. So my formula I know is going to be 1/2 base times height. Now a lot of numbers up here, so which ones are the distractors? The 5 and the 4.5. Okay, so just don't get stuck in that trap if you got to use every number or trying to convince you to use a different number. So it's just 1/2 of 7 times 3, which is then 10.5 square feet. Is that okay? All right. Next one. Next one's another triangle. Okay, so because it's a triangle, it's 1/2 base times height. I know my base and height are here and here because they form the right angle, but I don't know either of those side lengths. But I have a special right triangle. So go ahead and solve for your legs there. What do you do for your legs? 13 radical 2. All right, so now I can plug it in, right? So area equals 1/2. My base is 13 radical 2. My height is 13 radical 2. So what is radical 2 times radical 2? Just 2. 1/2 of 2 is 1. So really I have 13 times 13, which is 169 square units. Okay? All right, next one's a circle. This one's kind of nice, right? So area equals pi r squared. My radius is 3. So 3 squared is 9. And I don't care if you leave it as 9 pi squared centimeters. If you want to multiply it out, either way. Okay. Any questions on the basic shapes? All right. So I had mentioned that normally I teach like rhombus, kite, and trapezoid, right? But we can really just take those shapes and break them down into something that we already know. So we can break it down into triangles, parallelograms, and circles. Okay? So the first one, what shape is that? It's a rhombus. Good. So you have a couple of options. You could think about it in terms of two different isosceles triangles like this, right? So we can find the area of each triangle added together. They're going to end up being congruent. So really, I could find one and double it. Okay. You could also just look at it in terms of a single triangle and multiplying it by 4, because in this case, they're all 4 the same, right? So keep in mind, you can break it down into simple shapes. So let's find the area of just one triangle. So we have area of just one is equal to 1/2. I need the base and the height. My base is 6. What's my height going to be? Just this piece right here. I have a 30, 60, 90. So it's got to be 6 radical 3. Is that okay? Okay, so it's 6 radical 3. So then the area of just one triangle, half of 6 is 3. 3 times 6 gives me 18 radical 3. But I don't have just one triangle like that. How many triangles do I have? I have 4, just like that, right? I have 4 congruent triangles. I really need the area of 4. Do 4 times 18 radical 3. The area of 4 would be 72 radical 3 square units. I wrote that out in a lot of steps. Like, you don't necessarily have to write it out that much. Questions on that? Good. All right. Yeah, 44. 144. Okay, how did you do that? What did you put together?
Right. 6 is the base for one of the triangles.
Okay.
And 6 radical 3 is the height for one of the triangles.
Yes.
It's 36. Oh, I do have it for one of the triangles.
Okay, are you all right then?
Yeah,
Okay. All right, so the last shape then is what shape? It's a trapezoid. So let's break it into parts that we know. So with trapezoids, we can draw in a perpendicular, and I can divide it. In this case, it becomes a rectangle and a triangle, right? Sometimes you have to divide it twice, and it becomes a rectangle and 2 different triangles. But nonetheless, usually it's just a rectangle and a triangle. Okay. So think about the area of my rectangle. How do I find the area of this rectangle? I know opposite sides are congruent, right? So it's just going to be 12 times 11. Right? So my area is the base of my rectangle times the height of my rectangle. Plus I want to add 1/2 of the base of my triangle times the height of my triangle. I don't really care if you do subscripts. Okay, I don't care if you call them both B and H. Just understand the base of one is for my rectangle and the base of the other is for my triangle. Okay? I'm just doing this for you so that you understand there are 2 different bases. So the base of my rectangle is going to be 11. The height is 12. Now think about my triangle. If this whole side along the bottom of my trapezoid is 16, this little portion here has to be 5. So I have 1/2. The base of my triangle is 5. The height of my triangle is 12. All right, so let's clean that up. 11 times 12, that gives me 132. See, half of 60 then is going to be 30. If I add that together, I have 162. So 162 square units. Okay, so I'm not none of this here to be insulting today. Just making sure we understand where everything's coming from. We understand how 30, 60, 90s and 45, 45, 90s can play into this. Also understand how we can break a shape that we don't necessarily know the formula of into something we can find the equations for. Okay. All right, you have 4 problems left. I'm going to give you about 5 minutes here. I want you to take a look at these 4 problems. I do have a typo. On the very, very last problem, this should just be inches, not square inches. I know. All right, so I'll give you about 5 minutes here to work through those, and then we're going to talk about them. I'm going to even get that timer so I don't forget. Okay, stop yourself. Anyone need more time? All right, so let's start with these two problems here. So on these two, I'm just asking you to work backwards, right? So this time I'm giving you the area because it's a parallelogram. I know area is base times height. My area is 7.1. My base in this case is 2.3. I'm solving for my height. When you divide by 2.3, what do you get? 3.1. Is that one okay? All right, for my triangles, the area is 1/2 base times height. Telling me the area is 25. My base in this case is x, my height is 5. I multiplied both sides by 2 first to clear my fraction, so I had 50 equals 5x divided by 5, I had x equals 10. Good on that one? All right. Then I have two triangle problems, those are circles, two circle problems for you. So the first one here, I'm giving you that the area is 196 pi. So we know area is pi r squared. So 196 pi is equal to pi r squared. I need to solve my radius. So I can divide both sides by pi. That'll cancel out. So I have 196 is equal to r squared. Take the square root. I know my radius is 14. In this case, I'm going to know my diameter. I need to multiply by 2, and I get 28. In this case, 28 inches. Okay, last one then. I'm telling you the circumference is 30 pi inches. So circumference is 2 pi r. So 30 pi is equal to 2 pi r. I can divide by 2 pi. Okay, so if I divide by 2 pi, I'm left with my radius on the right side. Pi divided by pi, that's 1. 30 divided by 2 is 15. So I know my radius is 15. But I still need to find the area now, right? So area equals pi r squared. So pi times 15 squared, which gives me 225 pi. I don't remember what our units were. Is it centimeters? Inches? Sorry. Okay, square inches there. Not bad? I know that was a lot of notes for today. I was trying to give you a little bit of a picture of everything without being blindsided in your homework. All right, so I promise you, I don't know if you told me to put up, but there's going to be a homework test this 9 weeks still. Well, tomorrow's the last day we're here for the 9 weeks. You're saying something might be happening tomorrow. Okay, homework test? Just guessing. Yeah, settlement. Wow.
You're